So in this video, I make a circuit to implement what I simulated, hopefully, and found out a place where the boards can fit, and use pieces of cardboard to check. I mucked around with where the pieces are, with the terminal block was situated. I show the inrush protection for the capacitor boards, and some layout with KiCad 6 of a 4-layer board. Probably could have made it smaller, but I wanted to use through-hole components mostly because in some cases I'm not exactly sure if it'll work with the component choices I've made, so I want to be able to more easily swap them out. But I think at the end of the video I have a board which can be sent off to JLC PCB to be built. Anyway, I hope this is interesting for somebody. This is a circuit for the capacitor board. So this is an implementation, hopefully, of the simulation in the last video. So what the concept is that there's the main concept is that when you first turn this on, the filter capacitors charge through this 1.5 ohm resistor, so that stops the massive inrush current. And then after a certain period decided by this, then this relay will close, and then the input current will go through both sides. This relay here, I don't know why the symbol, I probably should have changed it. So this is normally closed, so it's shorting out this capacitor in the timing, the RC circuit. As soon as the 5 volts appears, then this relay will open and this will start charging. So the idea of this relay is to, as soon as the AC drops, then this relay will discharge this capacitor here, which otherwise, if you flick the on and off switch, you would still get too much transient current through this area. Just got to make sure, yeah, as soon as, so this relay is always power, the positive is always there, but the negative is controlled by this is a Schmidt buffer, not an inverter. I don't know why they made the symbol like that either. So that's directly at the output of the RC timing circuit. So this will go high and turn on the MOSFET. Now I've got two here because the actual IRML 250 is a surface mount, and it's rated at 4.2 amps, although it just seems incredible that that's possible. So I put another one in parallel so that I've got the footprint on the circuit board, so that I can put a TO220 in if this one's not suitable. That's just sort of paranoia. So yeah, the timing circuit is the input. So that's around the wrong way. The input to the Schmidt trigger, which turns on the MOSFET, which grounds the relay after the time period so that the low resistance path through it goes through here to the output. So from the simulation, I think the maximum peak is about 5 amps. So the RMS, I think the RMS is a bit lower than that. The RMS current, if there's such a thing. So hopefully this circuit is sufficient to, well, the main point is to make these capacitors last a long time, and I just wanted to have a circuit in the system with relays because it's just interesting. So I just do have a space problem. So this is the first version of the board, and it is 70 by 75, which does fit, and I took the precaution though of cutting out some bits of cardboard and taping them in. So you can see there, when I closed the case, I got the cardboard ripped on the wires. So it sort of works. I mean, I can probably move that. I probably will move that terminal block to the left a bit. So I think that version would fit, but I want to make another version. Just so I can't move the transformer any further. I've got about 40 millimeters. So the capacitors are the highest things, and they're at the moment on that version, the capacitors would be there where my hand is. So I think, yeah, so I move that left, push those wires, make the board shorter, and I'll try that and cut that cardboard down and see how that fits. So this is the next version, which is the same width. It's not laid out yet. Yeah, 70 by, and then how do I do this? 70 roughly. It should be 70 by 65, 60, 70 by 60. So I've cut off. I might be cutting off. Is it right? 65, 10 centimeters. Possibly. Yeah. So I think everything fits. I always try to keep the electrolytics away from the regulators, but this regulator shouldn't get too hot. And I don't think either one of these should need, well, that probably won't be populated because that's the spare spot, TO220 spot. Okay, instead of if this MOSFET it doesn't work as I expect it to work. Look at that. Yeah. So the mounting points, so it'll be each board. So there's two boards. There's going to be the two boards obviously side by side, and then 3 mounts. I may use this to connect them to each other with a little strap, but I'm not sure. So yeah, so the capacitors are at the bottom of the case and at the left, and all the connectors. So I avoided connector here because on the right hand board that might interfere with the bridge, but I'll probably plug all the wires in and then put the boards in the same way that I have to do with the regulator boards. So I'll lay that out in time lapse and see how this goes. I usually use 4-layer boards because it feels lazy, but they're nearly no difference. There's hardly any difference in price, and it just makes everything a lot easier. So the board's laid out in its shrunk form factor, and seems to look okay. I've used through hole mostly because some of the components I'm not exactly sure, so I'll have to be tuned a little bit. I think this is ready to be sent for fabrication. Yeah. So I moved this. I was trying to look to the left as far as I could practically do it, and move these wires a bit down like that. And I've made new templates, so they're pushed in. So now, so if I push that down like that, hopefully. That didn't sound good, and now I can't get it off. But that's pretty good. So it doesn't go anywhere near them. If that was visually okay, let me have a look. So hopefully when the capacitor boards come back and I make them, this power supply will be finished and working, and I can stop using it as a way of procrastinating. Anyway, I hope that's interesting for somebody. Thanks for watching.